So in this section, we want to practice graphing nonlinear functions by just plotting some ordered pairs. And that'll give us a good idea of what the shape looks like, which we'll memorize in the next section. So our first example, graph f of x equals negative x squared. So we don't have any points. We're just going to choose one of the variables, solve for the other one, since this is solved for y, because y is a function of x. Then I'm going to choose some x coordinates. Let's choose a -2, a 0, and a +2, and see if that gives us a good shape here. So if we evaluate the function at -2, then that'll be negative of -2 squared, and that'll be negative of 4, or -4. For 0, that's going to be -0 squared, and 0 is neither negative nor positive, so just 0. And +2, let's put that into this function, and that's going to be negative of 4, which is -4. So let's plot some of those points. Our first is -2, so from the origin left 2, down 4. Plot that point. 0, 0 is right at the origin. And +2, -4. So does that give you a good idea of what this graph looks like? Let me fill in a few more points here. How about a +1 and a -3? Okay. So +1, let's put that in for x. That's going to be opposite of 1, or -1. And for the -3, that's going to be the opposite of -3 squared, or opposite of 9, so -9. Alright, let's plot those. 1, -1, and -3, -9. That gives me a better idea of what this looks like. So this is going to be curving this way, and curving this way. And that's a parabola shape, which is expected for any quadratic function. Number 2, we're going to graph f of x equals the absolute value of x plus 1. So again, I want to get some good ideas of what some negative values look like, 0, and some positive values. Doesn't matter what they are. We're just choosing the x so we can solve for y. So f of -5, we're going to put that in for x, and the absolute value means distance from 0, so that's 5 units. Plus 1 will give me 6. Let's try -2. So absolute value of -2 is 2 units from 0. Plus 1 is 3. F of 0, the absolute value of 0 is no units. Distance from 0, because it is 0. Plus 1 more. A +2 is going to be 2 units distance, plus 1 more, so 3. And lastly, f of 6, so a distance of 6 plus 1 more unit is 7. Okay, hopefully this will give us a good idea of what this looks like. So -5 and +6, plot that point there. -2, +3, 0, 1, 2, 3, and 6, 7. Okay. Definitely can see what this looks like here. It's going to be like a line going off that way, a line going off that way. Kind of looks like a V shape here. And a third graph, f of x equals the square root of x minus 1. So this one can be a bit of a problem because the square root only has a certain domain for the x variable, meaning I cannot put whatever value I want in here because what's inside of the square root has to be greater than or equal to 0. Because remember, when you square root a negative number, that is not real. And these are real number lines, right? So I can't graph things that are not a real number. So if I add 1 to both sides, I'll see that the domain has to be greater than or equal to 1. So let me choose 1. That'll be my starting point. My next point, I don't want to use well, I could use 2 because 2 minus 1 is 1, and there is a square root of that. Well, let me just work with what I already have, and then I'll continue. So 1 minus 1, that's the square root of 0, which is 0. Then 2 is the square root of 2 minus 1, which is the square root of 1, which is 1. Okay. 3 is something I don't want to use because then I'll have the square root of 2, and that's not something I'm going to graph. So the next perfect square will be 4, and that'll happen when x is 5. So that'll be the square root of 5 minus 1, which is the square root of 4, and that's 2. And then the next one, the next perfect square is 9, right? So what minus 1 equals 9? That'll be 10. So if I make x 10, then the square root of 9 is 3. Let's graph those points and see if we have a good idea of what this looks like. So 1, 0, 2, 1, 5, 2, and 10, 3. So we can see that there's nothing to the left of this, right? Because of our domain, we start at x equals 1, and that's as far left as this goes for the graph. So this is our starting point, and then we continue curving off this way. And that's what the square root function looks like.